Solubility curves. When the solubilities of a solid in a given solvent are plotted against their respective temperatures, a solubility curve is obtained. It is a graph that shows the effect of temperature on the solubility of the substance. Let's consider the solubility of potassium chloride and potassium triazoochloride 5 as shown on the board. The question says, what is the solubility of potassium chloride in grams per dm cube at 0 degrees Celsius? Now we are given the relative atomic masses of potassium to be 39, chlorine to be 35.5. The options are A, 26.075 gram per dm cube, B, 260.75 gram per dm cube, C, 2.6075 gram per dm cube, and D, 0.26075 gram per dm cube. From the graph, the solubility of KCl is 3.5 mol per dm cube. Solubility of KCl is 3.5 mol per dm cube. So to express this in gram per dm cube, we simply multiply by the molar mass. Molar mass of KCl is 39 plus 35.5, that is 74.5. Therefore, solubility in mol per dm cube is equal to 3.50 multiplied by 74.5. That will give us a total of 260.75 gram per dm cube. From the solution as shown on the board, the solubility is 260.75, and consequently the correct option is B. Example 2. Let's consider the graph. If 1 dm cube of a solution of KClO3 is cooled from 50 degrees Celsius to 20 degrees Celsius, what mass of the solute will crystallize out? The options are A, 22.5 grams, B, 2.25 grams, C, 225.0 grams, D, 0.225 grams. From the graph, the solubility at 50 degrees Celsius is 4.5. And the solubility at 20 degrees Celsius is 2.5. Therefore, difference in solubility is 4.5 minus 2.5, that is 2.0 mol. Therefore, the mass of salt that crystallizes will be 2 moles multiplied by the molar mass, that is converting the moles to mass. Now, molar mass of KCl is 39 plus 35.5 plus 48, giving us a total of 112.5. Therefore, molar mass of KCl3 that crystallizes is 2.0 multiplied by 112.5. 0.5, giving us 22.52 grams. From the solution on the board, the correct option is 225 grams. Consequently, the correct option is C. Example 3. Consider the solubility curves of potassium trihydrochloride 5 and sodium chloride. With the solubility curve of potassium trihydrochloride 5 and sodium chloride, which method will be used to separate a mixture of KClO3 and NaCl? The options are A. Evaporation, B. Crystallization, C. Decantation, and D. Evaporation. Now from the graph, there is a sharp difference in the solubilities of the two salts, and hence the method of separation will be crystallization, because it is a technique that utilizes the principles of difference in solubility. Example 4 shows the solubility curve of sodium chloride. From the graph, what is the solubility of sodium chloride at 25 degrees Celsius? The options are A. 0.31 mole per dm³, B. 0.41 mole per dm³, C. 0.38 mole per dm³, and D. 0.45 mole per dm³. Let's now consider the solution. Now from the graph, with 25 degrees Celsius, when the line is straight from 25 degrees Celsius to the graph, it gets to the graph, and when drawn towards the solubility axis, it is about 0.31, and consequently, the solubility of the salt at 25 degrees Celsius is 0.31 mole per dm³. So the correct option is A. Example 5. From the graph, at what temperature will the solubility of sodium chloride be 0.15 mole per dm³? The options are A. 25 degrees Celsius, B. 15 degrees Celsius, C. 30 degrees Celsius, and D. 10 degrees Celsius. Solution. When you take a look at the graph, on the solubility axis, at 0.15, when the line is drawn to the graph, and this line is produced towards the temperature axis, it falls on 15. And so, the temperature at which the solubility of sodium chloride will be 0.15 mole per dm³ is 15 degrees Celsius. And consequently, the correct option is B. Example 6. The solubility of gases decreases with a rise in temperature, with the exception of, let's consider the options. A. Hydrogen sulfide, B. Carbon 4 oxide, C. Hydrogen chloride, D. Sulfur 4 oxide. Let's now consider the options one after the other. Hydrogen sulfide has a solubility that increases as temperature increases. B. Also, carbon 4 oxide, the solubility increases with rising temperature. C is the exception. Hydrogen chloride is a peculiar gas. The solubility decreases as temperature increases. It is an abnormality, but it is only hydrogen chloride gas that behaves that way. D, sulfur 4 oxide, the solubility increases as temperature increases. So the correct option is C.